Okay, everybody, thanks so much for your interest in this event. Thanks for coming. My name is Chin Zhu. I'm a research assistant professor in the Division of Humanities, Arts, and Social Sciences, and also the Ethics Across Campus program. Today, this event is funded by the Daniels Fund program in professional ethics education. The program itself the major goal is to support ethics integration activities on campus, and we recently created this new lecture series on ethics of emerging technologies. Today we have Dr. Christopher Preston, and in the future we're going to organize other similar events, such as topics might include the ethical significance of sending messages to outer space, and also ethics of robotics. Like next semester we'll be organizing a panel on ethics of robotics and cybersecurity. Today, we're very lucky to have Dr. Christopher Preston to give us this lecture titled The Synthetic Age, Out-Designing Evolution, Resurrecting Species, and Re-Engineering Our World. Let me say a few words about Dr. Christopher Preston's background. Dr. Christopher Preston is a professor in the Department of Philosophy and a research fellow at the Mansfield Center's program on ethics and public affairs at the University of Montana. He works in environmental philosophy, climate ethics, and the ethics of emerging technologies, and feminist philosophy. His books include Saving Creation, Nature and Faith in the Life of Holmes Rostand. Third, for people who know Rostand, you know it's one of the founding fathers of environmental philosophy in the world, in the U.S. And Grounding Knowledge, Environmental Philosophy, Epistemology, and a Place, that's published by University of Georgia Press in 2003. And his newest book, The Synthetic Age, was recently released by the MIT Press in March 2018. With that, let's please join me in welcoming Dr. Preston.
How's that? Is that all right? Well, thanks for coming out, everybody. Really appreciate it on a gorgeous day. Chin, thanks for organizing, helping me get down here. Chin mentioned Holmes Rostand III. 25 years ago, I came over from the UK to study environmental philosophy up in Fort Collins with Holmes Rostand, who's still there. He's still kicking. I love coming back to Colorado. It changed my life coming over here. And so it's always nice to be here. And the sun that you have here, I came from Montana this morning. We've had a La Nina winter where it's been very gray, quite snowy, but very gray. So to see all the sun is really something. So I'm going to talk today about two ideas, one of which I think you'll be quite familiar with, the Anthropocene, but don't worry if you're not, because I'll introduce it a little bit. And the second idea I think you won't be familiar with. It's the idea of the synthetic age. And it's a term that I've just started using. And so I definitely will have to introduce you to that. But the idea of the Anthropocene, how many of you, if just quick show of hands, because I want to make sure I'm not giving you useless information. Quick show of hands, have you heard of the Anthropocene? Okay, almost everybody's heard of it. So it's the proposed name for the geological epoch that we are supposed to be entering, right? It's just a proposal right now. It hasn't been confirmed. There's a long sort of process of geological epoch naming, which takes a few years. And we're on the way in that process, but it'll be a while before it becomes official. But the Anthropocene will be the latest geological epoch following the Pleistocene, following the Holocene. And there's fairly widespread agreement that we're there. We're in the Anthropocene. And there was a paper published in 2016 by this Anthropocene working group suggesting that there is enough disturbance to Earth systems globally that future people looking at the stratigraphy will find evidence that this is indeed a human-dominated epoch. And the evidence that appears in the working group's research is all this sort of stuff, familiar stuff, carbon dioxide in the atmosphere, extinction rates, pesticides all over the planet, PCBs, methane, so on and so forth. So all of these factors are part of what make the Anthropocene the current epoch that we are entering. The term was coined by a Dutchman, Paul Crutzen, and an American, Eugene Stormer, who in 2000, just apparently spontaneously at some meeting, kind of came up with this idea: why is everyone still talking about the Holocene? We're in the Anthropocene, the human age. And that term has a sort of felicitous sound to it, Anthropocene. It's a really nice word. And it kind of stuck. About 8 years previously, a New York Times journalist had said, let's call the age we're in the Anthropocene. Left out that middle syllable, the Anthropocene. And it didn't stick in the 1990s. But in 2000, the Anthropocene with Crutzen and Stormer, that name really stuck. Now, it wasn't just the name, right? It really stuck because climate change, I think, by 2000 was so much on people's minds. It was so much part of a public discourse that when a couple of people stand up and say, the world is now influenced by humans, climate change is sort of a signal that, yeah, you can't really deny that anymore. And so since those early years of the Anthropocene discussion, people have basically acknowledged that it probably is climate change that has really pushed this discussion forward. And many of you might have read or heard of this book by Bill McKibben. Bill McKibben's famous for being the founder of 350.org, the activist group that's advocating for bringing carbon concentrations in the atmosphere down to 350 parts per million. So Bill McKibben, before he was an activist, he was a writer, and he wrote this book, The End of Nature, in 1989. And The End of Nature was effectively saying, he didn't use the word Anthropocene at the time, but The End of Nature was effectively saying, nature's gone. We're out of the Holocene now. Something else is happening. And so I think you can think of the Anthropocene as really a case where at one point the planet was one thing, and we called the epoch the Holocene. And then climate change happened. So this is the famous Keeling curve, which tracks carbon dioxide concentration since the 1950s. Something happened, and then that planet became something else. And McKibben actually uses these terms. He says, Earth 2. We were in the Holocene, and that was Earth 1. And now things have changed through climate and then these other factors. And so now we have arrived at Earth 2. And so the Anthropocene has really become a scene. And look at the slightly different spelling on Anthropocene there. This word has really caught fire. I don't know if you've sort of experienced this, but it's not often that terms in geology sort of enter into a sort of public lexicon in the way that this term has. I mean, it's everywhere. It's in all the sort of popular media. And people are suggesting, alternative names for it. I've heard the Eurocene, the Manthropocene, right? Feminists are keen to stress, who's caused all this damage. The obscene, perhaps. I've also heard it called the Trumpocene, right? And, any time that a meme sort of spreads this widely, it's kind of outgrown its origins. And certainly the idea of the Anthropocene has outgrown the geosciences. One theorist calls it a charismatic mega category. And I think that's kind of right. Like the Anthropocene is now all encompassing. So my work is sort of in the Anthropocene, but I think there's a problem with this term. And what is the problem that I think this term has? The Anthropocene is really a scene of careless mess. So if you think of the things that characterize the Anthropocene, so we've got greenhouse gases, we've got pesticides, we've got species extinctions. None of these things were deliberate attempts by humans to shape the planet. All of these were side effects of efforts that were made for other purposes. So greenhouse gases, Nobody said, let's burn some fossil fuels and heat up the planet. That sounds like a good idea. That wasn't the intention. Like, the intention is to increase standards of living, lift people out of poverty, get yourself from A to B in a fossil fuel powered vehicle. So the intention is never to shape an epoch. And so it's a little odd, I think, to call it the Anthropocene, as if humans are shaping the epoch. Because to me, the Anthropocene is a little bit more like a spilled cup of coffee. And when I think of a spilled cup of coffee, I try and imagine, I picture this, breakfast time, right? You're looking forward to a really good breakfast. You got the newspaper spread out on the table. You got your smartphone. You got the coffee brewing. You got cereal poured already. You're coming towards the table with your coffee and you trip over the dog. The coffee spills. You try and grab it. You knock the cereal over. The cereal falls on the dog. The dog's got fruity pebbles on its head. Whiskers are dripping with milk. Paper is ruined, smartphone is damaged. Your partner walks in the room and says, "What happened?" And you say, "The Anthropocene," right? It's an odd name because it's really just a giant oops. We didn't mean to do that. So I like the Anthropocene as a term, but I don't think it's the right way to describe where we're at or where we're heading. Where we're heading, I think, is somewhere much more serious, somewhere much more dramatic. Because I think what is happening at this time, what is happening at this moment in history in which we live, is that we're on the point in moving from accidental planet shaping, which was the Anthropocene, from that to deliberate planet shaping, intentionally shaping the way the planet works as a whole and the way that particular functions, planetary functions, operate. We are on that point, on that cusp. And so I call this time that we're in the synthetic age, which I think is something really quite different. And most of what I'm going to do today is explain to you what I think the synthetic age is. But just to give you a little hint of it, I want to read just 2 paragraphs from the intro to this book. This is kind of the setup for this synthetic age. In the 1967 movie The Graduate, the dazed-looking hero Benjamin Braddock, played by Dustin Hoffman, is pulled aside by a well-meaning family friend and told that the key to his future can be found in a single word: plastics. Have you seen the movie? It's kind of an oldie, but it's kind of a classic. Plastics. As the friend saw it, an awful lot of the stuff Ben would see around him was going to be synthesized in factories using new types of cheap and highly flexible chemical processes. If Ben knew what was good for him in his career, he needed to make himself a part of it. Today, if Ben were getting such advice, he would hear a much grander promise of an even more startling synthetic future. Humans are no longer just surrounding ourselves with new materials. Our species is also gaining the ability to re-engineer a number of key planetary processes. We are learning how to synthesize and stitch together new arrangements of DNA to build original and useful organisms. We are fabricating novel atomic and molecular structures to create entirely new material properties. We are reassembling the species composition of ecosystems while experimenting with bringing extinct animals back from the dead. We are studying how to deploy technologies that will turn back the sun to keep the planet cool. In each of these ways, humanity is learning how to replace some of nature's most historically influential operations with synthetic ones of our own design. So, like I said, I began my life in environmental ethics, but up at Montana, we sort of started getting interested in technologies and how technologies transform the relationship between humans and nature. And we got on a couple of NSF grants and worked in areas such as the ethics of nanotechnology. And actually, 7 or 8 years ago, I was on campus here at Mines when you were doing some nanotechnology ethics stuff. So I really enjoyed being down here then. Nanotechnology, synthetic biology, GMOs, genetically modified organisms. I worked in that area. Climate engineering. We had a big NSF grant on climate engineering. So after a while, I'd worked in all these different sorts of areas, and I began to see a pattern in the ways these sorts of technologies worked. What I found is the kinds of things I was saying in my nanotechnology papers were actually the same things that I was saying in my climate engineering papers. And I thought, I must be really boring. You know, I keep saying the same thing in these different arenas. But then I thought, no, I'm saying the same thing in these different arenas because the same thing is going on in these different arenas. And so you can put it all together and you can tell a larger kind of story about the synthetic age. And in rough outline, this is what the larger story is. It's that the synthetic age is the age in which we start deploying practices and technologies that really get under the skin of the Earth. So I use the word metabolism there. I use it really as a metaphor. So, you know, I don't think the Earth is alive. I don't think that, you know, there's this thing called Gaia, which is this sort of living organism that is the Earth. I use it metaphorically. But I think these sorts of technologies get under the skin. They're not cosmetic changes to the Earth. It's not like ripping out a forest or scratching the surface by doing some mining. These are technologies that actually get inside and replumb or rearrange the Earth. So I think of it, you know, compare a cosmetic surgery to heart bypass surgery, or something that replumbs your digestive tract. These are the sorts of technologies that I think we're talking about. I'm going to illustrate this now with several examples. So I said I'd worked on climate engineering. How many of you are a little bit familiar with climate engineering? Okay, one form of climate engineering is an attempt to reflect more of the incoming solar radiation back out into space before that incoming heat has had a chance to kind of get down into the lower portions of the atmosphere, down into the terrestrial surface or down into the ocean. So if you can reflect some of that heat back out by perhaps putting more white clouds up there or something like that, then you can hopefully cool the planet down a little bit. So this is an image of a compilation of climate engineering strategies. Now, I put this up because it's just a sort of fascinating image to look at. It's too full for our purposes. As you look at this, just notice that some of these climate engineering strategies have CC written alongside them, and those are carbon capture strategies. And that's definitely part of the climate engineering discussion, how to pull carbon out of the atmosphere. But the ones I'm interested, for the point I'm trying to make right now, are the ones that have SR alongside them. So solar reflectance or solar radiation management, as it's usually known as SRM, solar radiation management. And those are the ones that put some sort of reflective barrier either up in space if you've got orbital mirrors, or in the stratosphere if you're talking about airplane emissions or dusts or particulates, aerosols, or lower down in the troposphere if you're trying to make ocean clouds. And then there's various other sort of things like painting roofs white, that sort of thing. All of these technologies, all these techniques, they reflect solar radiation. They bounce it back up into space, hopefully before it warms anything else up. Now, why does that get into the planet's metabolism? It puts human intentionality, and this is the key for me in a synthetic age, human intention gets into a formative process. And it seems to me that like the amount of energy that arrives at the planet's surface from the sun, you know, if there is ever a formative process, that is one. Like that's a really important planetary process. And unlike what we were discussing earlier, the Anthropocene, that big accident where a bunch of stuff happened unintentionally, what climate engineering would do would be to intentionally shape that planetary factor. So that's one example. Synthetic biology. So here we're talking about building genomes in the lab from constituent chemicals. So the state of the art right now is you look at the genomes of some very simple bacteria. you read them, you map them, then you take that map into the lab, you get your bottles of chemicals, and you stitch that genome together in the lab. When you've stitched it together, you grab it, you take it back out of the lab, you get hold of a bacterium, and you stuff the genome in it. And that genome then takes over the operation of that bacterium. First time this was done, it was in 2010, and it was a model of Mycoplasma mycoides, I think it was. In 2016, the same scientists that achieved that breakthrough in 2010 took the genome that they had made in 2010 and they stripped it down into the minimal components needed for life. So they created a whole new genome. Evolution, it sort of heads in a certain direction, but in a really crooked kind of line. There's a lot of extraneous genetic material. So what they did between 2010 and 2016 is they stripped the genome down to its bare minimum, shoved it into a bacterial host, and it took over the operation of that cell. So why is that part of the synthetic age? It's the same thing about intentionality. Just as with climate engineering, it was about intentionality. So here, it's about intentionally bringing design into living organisms. Let me give you a couple more examples. Gene drives. So gene drives are techniques for spreading certain genetic traits out into wild populations. Nobody's done this yet, but they know it can be done. Why would you send a trait out into a wild population? What if you had a wild population that was doing something you didn't want it to do? And you figured if you could send a certain gene, some sort of terminator gene, out into that population, perhaps you could extinguish that population or stop it breeding or something like that. So people talk about this in relation to the Zika virus, dengue fever, people who are worried about the predatory instincts of rats and mice. It has to be a very fast breeding organism. If you're going to send a gene drive out into nature, the organism has to breed very fast. Because what you're doing with a gene drive is you're biasing inheritance. So a trait that nature wouldn't really select for, you're biasing inheritance so that in that second tree there, what you see is the trait gets spread through the population, really against what nature would do by itself. So gene drives, they do the same thing. They put intentionality into natural selection, basically. They put human intentionality into the process of natural selection. I've got a couple more examples. These examples, actually, the last couple of examples I'm going to give, they're not as highly technological. So I sometimes use the term Anthropocene technologies and practices. Some of them are technologies, very advanced technologies. Some of them are simply practices. An assisted migration of endangered species, I think, counts as one of these practices. What is assisted migration? If you have a species in an area where it's starting to feel the stresses of climate change, you might hope that species could sort of move itself into a cooler environment. But of course, that's not always going to be possible. Sometimes there isn't the habitat in between. So think of, in Montana, we talk a lot about our pikas. So these are high altitude little, they're actually, I think they're in the rabbit family, but they look like a little sort of marmoty thing. They live up mountains, right? If they want to move north, they would have to come down mountains, move north, and then go up other mountains, and they can't do that. Butterflies, another thing. Some butterflies migrate long distances. We all know about the monarch butterflies going down to Central America. But other butterflies just don't like to move very much. So on the bottom right there is the marbled white, which is a British butterfly that actually kind of likes to stay put. And it's getting too hot in its native range. So assisted migration is the idea of moving, going in there, grabbing the species, moving it north to put it in a place where it's more likely to survive. We've got white bark pine in the top right there, dying all over Montana because of blister rust and pine bark beetle. And we've got Torreya taxifolia on the top left, which is in Florida, not doing very well in Florida. So assisted migration. And then this technology, de-extinction, so this employs some of the techniques that I was talking about with synthetic biology and with gene drives to recreate extinct species. Hasn't happened yet, but there's research going on as we speak on this topic on the passenger pigeon, bottom right there. And the woolly mammoth genome has been sequenced. We're sort of ready to think about de-extincting the woolly mammoth. So assisted migration and de-extinction, same thing, right? They bring human design and intention into processes that shape ecosystems. And my last example actually is hardly a technology at all. But it's this phenomenon of the spread of light. And through the spread of light, the extinguishing of night. So Paul Bogard wrote this lovely book called The End of Night. If you end night, and you end night by putting lights everywhere, basically, and not turning them off at night. If you end night, dramatic things happen to organisms and to the ecological arrangements in nature. So everybody knows, I think, about the leatherback turtles. They used to come out of the ocean onto a sandy beach and would navigate by the light of the moon and then find a place to bury their eggs. Slow, laborious kind of process. And then beachfront hotels started appearing on those sandy beaches. And the turtles would come out of the water and they'd head one direction and they'd see a light somewhere else and they'd head another direction. And it really messed with their breeding potential. So the end of night had consequences for leatherback turtles, and the end of night has consequences for peregrine falcons. This one's actually a slightly happier story. So peregrine falcon, fastest animal on Earth. So they're famous for swooping down. They call it actually a stoop, where a peregrine falcon nesting high on a cliff sees some prey, tucks its wings, and heads down at up to 200 miles an hour. And then just as an interceptor missile doesn't actually need a warhead, all it has to do is hit the other missile to destroy it. So all does the peregrine falcon have to do at 200 miles an hour is just a glancing blow on a duck or a pigeon, and that bird is theirs. So these peregrine falcons, living in cities now, they like tall buildings as much as they like cliffs, have found that they can hunt effectively at night without doing all this 200 mile an hour business. They can fly low and they can look at birds, ducks and pigeons, moving through the dusky sky, and their bellies are illuminated by all the city lights. So the falcon starts low and then sees these illuminated bellies and then flies up and grabs the bird from beneath with its talons. And so in that case too, I think it's not, this case is not quite the same. It's not in that humans are designing a world so that these things happen, but humans are intentionally ending night. We find reasons why we want to spread illumination around as much as we want, and by doing that, we create these rather perhaps unfortunate, sometimes fortunate kinds of occurrences. But we definitely shape the system in a way. That's why I put this ending of night in the same category. There is a shaping of the system going on here through human activities. So if we can just revisit where we were at the start, we had spoken about this initial Holocene epoch, and then climate change comes along, and we have an Anthropocene. My contention would be, so this is the accidental planetary effect we've had. My contention would be that we're now, if we ever were in the Anthropocene, we should now replace that idea with the idea of a synthetic age, an intentionally shaped planet. And I think one might perhaps call this Earth 3. A different kind of planet, one that is answering to our design and to our intentions. Now, what do I think about that? What should we think about that? Well, here's something to notice. The Anthropocene, remember, is an accident. A lot of people, when they contemplate the Anthropocene, they think, we really screwed up. You know, this was really a bad deal. We shouldn't have heated up the planet. We shouldn't have put toxins in the livers of polar bears. We shouldn't have allowed this bioaccumulating poison that spread around the Earth. So a lot of people think of the Anthropocene as a sort of unfortunate kind of mistake. But there is a risk that the Anthropocene can sort of drift down or get ratcheted down into this synthetic age where the sense of mistake is replaced with the sense of, we got this. We can control this planet. And so you see next to the little arrow there, I put the hubris level. So hubris is just sort of a fancy word for overconfidence or arrogance or something like that. There is the potential for people to think about the synthetic age with slightly too much self-confidence. And actually, if you look at some of the things that some of the thinkers in this area are saying, you do have to wonder if they aren't approaching this forthcoming epoch with slightly too much confidence, perhaps. Are we really the God species? And is it really for us to design nature, to decide even what nature is? There's the possibility that our hubris level might rise too high. We tried this. So we tried this idea of building a planet about 20 years ago in the Arizona desert. People familiar with the Biosphere 2 experiment? So the intention was to create this self-contained ecosystem in which humans could live. And the idea was they were going to put 8 bionauts, they called them bionauts, not astronauts, bionauts, into this enclosure for 2 years. And they sort of figured out, how are we going to generate enough oxygen? How are we going to dispose of waste? How are we going to produce enough food? The idea was we would show that we could design, it's not a planet, but show that we could design a system in which people could live indefinitely. And it didn't work. It didn't work because some of the engineering was off. There were basically some pretty big mistakes made in terms of designing this system. But another reason why it didn't work, actually, was the social element. It didn't work because 8 people cooped up in a glass house for 2 years. It doesn't necessarily go so well. And so, but this is sort of a serious point. It's not just, when you try to engineer something, it's not just that you need to get the sort of physical, chemical, biological systems right. You also need to get the human systems right. If you don't get the human systems right, things are not going to work out too well. And it didn't work out too well in Biosphere 2. So this is the picture that I'm trying to describe. This Anthropocene that everybody is talking about is, for me, a moment. So it's a moment where you say, humans have planetary impact. The consequences of our actions are planetarily significant. But it's a moment from which you sort of make a decision, like we've come from the Holocene past, and then the question is, are we really going to head enthusiastically into this synthetic future? And a lot of people do see this as a fork in the road in the environmental community. So I just want to sort of stress again, I come from environmental philosophy. I don't come from engineering ethics. I come from environmental philosophy. So in the environmental community, people really do see this as a fork in the road. It's a fork in the road between a past that is sort of filled with these magical types of creatures, some of which are extinct, but many of which are still with us, and a future that is almost unrecognizably different. This is the choice that I think we're sort of standing at the moment of this choice. So, all right, we got a choice. Which way do we go? Let me tell you why I wrote this book. And this is also, I'm just going to read you another little passage from the intro. This is part of the setup of the book. Understanding the character of these transformations is important because crucial choices need to be made. The exact contours of the path ahead are not yet fixed. We need to decide how far into remaking the Earth we should go. Although some level of management of natural processes is now inevitable, the synthetic age could still take many different forms depending on how aggressively we choose to impose our designs. According to one approach, the new relationships to the Earth required in the coming epoch will finally reject the idea of stepping back and making an effort to diminish our footprint on the planet. Instead, it will quickly ramp up human intervention into nature and its processes. Rather than impacting nature thoughtlessly and accidentally, a full throttle synthetic age means we would shape it confidently, deliberately, and sometimes ruthlessly, all according to the best abilities of our technical experts. Nothing would be off limits. Others, though, balk at this high level of intervention and see the dawning of the new epoch as an opportunity to dial back our meddling. Even as we intensify the management of nature in some areas, we could become increasingly less involved in others. By choosing to treat certain stretches of DNA as inviolable, for example, we could ensure the protection of some portion of what evolution handed down to us. By designating some landscapes as entirely off limits, we could preserve some important symbols of the Earth's wildness and independence. At the same time that we encourage the development of certain planetary scale technologies for humanitarian reasons, we could push back against other aspects of an increasingly synthetic world. With many of the questions about the shape of this synthetic age still unanswered, we occupy a crucial transitional moment, a fleeting opportunity for reflection as the planet enters a different period of its history. So the book sets this out as a choice. And for the most part, when I wrote the book, I was trying to be totally neutral on it. And as the book kind of got close to the publication, the editor comes up to me and says, "Christopher, you can't be totally neutral on this. You know, you gotta write a book where you kind of plant a flag and you say kind of where you stand on this." And so I took that into advice a little bit, and I did end up being a little bit more on one side rather than the other, but I still maintain that a lot of these questions about how synthetic should we go, how much control should we exert over these planet-shaping processes, a lot of these are very, very difficult questions to answer. And I use this quote from a guy at the University of Wyoming who actually kills locusts for a living. So his job is to design the poisons that go on agricultural fields to kill off locusts. And he says it's easier to be a member of Earth First or the Chemical Manufacturers Association than a member of neither. And he finds himself in this position of sort of sympathizing with both sides of the issue. And that's definitely where I find myself, sympathizing with the climate engineers. Some of my best friends are climate engineers. It's not quite true, but I know a bunch of climate engineers or prospective climate engineers, and they're good people. And the same in these other kind of areas of synthetic biology and nanotechnology. And so definitely it's easy to sort of say none of this is going to be any good. And as an environmentalist, if you say no to nanotechnology, you're saying no to efficient solar panels. Why would you do that? If you say no to synthetic organisms, you're potentially saying no to the key to cheap and effective biofuels. Why would you say that? So environmentalists tend to reject a lot of these technologies very quickly, and I suggest they shouldn't do so. But having said that, here's where I think I kind of stand on this idea of a synthetic age. So I'm getting sort of into the latter little portion of my presentation here. So why have I put this place up? This is where I'm from. So this is southern England, East Sussex. And this particular place is called Firle Beacon. It's called Firle Beacon because in the days where they used to build big bonfires on tops of hills to communicate, they would put one here over to the right side there, Firle Beacon. They'd light a big fire, and then 15 miles away they'd light another big fire, and messages could be sort of passed across the country from beacon to beacon. It's a lovely part of the world. When I go back, I really enjoy it more and more. But you look at this landscape, and it's shaped. It's not like the landscape that I look at out of my hotel window in Golden. That landscape's more raw, more as geology meant it to be. This landscape is more shaped. Sheep have grazed those hillsides for hundreds of years. The forests have mostly disappeared. The landscape's farmed. It's beautiful, but it's a shaped landscape. And so you would think that people from this sort of landscape, so I'm now broadly saying Europeans, people who live on landscapes that have had long human histories, long histories of being shaped in order to further human interests, you'd think that people from these landscapes would embrace the idea of an Anthropocene or a synthetic age. But in fact, that is not what is happening. And I'm switching a little bit now from my sort of technology hat to my environmental ethics hat. Because in Europe, there is an enormous push right now towards rewilding. Rewilding is the idea of bringing back natural processes onto landscapes, bringing back animals that have been made extinct, at least locally extinct to that part of the world, and also bringing back processes. So I had a sabbatical in the Netherlands, and I got to sit down with the head of Rewilding Europe for coffee to talk about it. And the first question I had, it was kind of like an interview, and I had some questions for him. First question I had is, all right, what animals are you working on in Rewilding Europe right now? And he kind of slumped his shoulders and he said, don't always ask about animals, ask about natural processes. Ask about floods, erosion, geomorphology. What I'm trying to do is restore natural processes to this world that we have shaped so much. And this guy is Dutch, right? So, you know, the Dutch have reclaimed their whole landscape from the ocean. And as a Dutchman, he is saying, we want these processes to be brought back. We want nature to be operating independently of us. And in Europe, this is a really interesting map. So essentially what you're looking at is green areas there are depopulating. You know, you think Europe's got a lot of people, right? Highly industrialized in many places, and yet all over Europe, these areas are depopulating because of various agricultural efficiencies, because of the impact of the European Union and the way goods sort of move around these nations. So all of these different areas, so you know, the Apennines here, on the Iberian Peninsula here, these are all areas where Europeans are trying to put wild animals back into a landscape. They're trying to let nature be nature as opposed to continuing the sort of human intentional design and influence that characterizes most of the urban areas there. There's this place in the Netherlands called the Oostvaardersplassen, and they call it new nature, which is an interesting idea. It's almost oxymoronic, you know, like, can you make new nature? Like, can humans make nature such that they have new nature? It's almost oxymoronic, but what they've done is they brought some animals back, they've allowed rivers to flood, they allow populations to bloat up and then die back. They're letting nature run its course in the Oostvaardersplassen. And I'm giving you these examples from Europe because what I think they indicate is that one's enthusiasm for a synthetic age will only go so far. There's lots of things to like about a synthetic age, but there's lots of things to like too about that Holocene past, which we can never perfectly recapture, right? But there's lots of things to like about that past where these systems were not managed by humans, not totally designed by humans. And I think that's the countervailing point to the Anthropocene and to the synthetic age. And so I'm going to get philosophical on you at the end here. So this is John Stuart Mill. Some of you might know him as the great utilitarian. And he described nature as the cradle of our thoughts and aspirations. And for me, that sort of captures this idea that there's this background to all of our lives, this undesigned, unbuilt background that people think are important, people think is important. And so when a synthetic age comes on, or the potential of a synthetic age, we run the risk of losing that background where the whole of nature becomes artifacts. Everything that is found becomes made. That's what's at stake in a synthetic age. The found becomes the made. And so it is fundamentally a philosophical question about proper relationship with the world around us. In this full throttle Plastocene, the biosphere becomes the technosphere. What is around us becomes what we design. In a slightly more humble synthetic age, we deploy these technologies in certain areas, but we deliberately withhold them from others. And we try and maintain processes that are not shaped in any way, if possible, to the extent possible, not shaped by humans. And so Sunday is Earth Day. April 22nd is Earth Day. So it's kind of good timing, Chin. Thanks for bringing me here now, because I'm able to deliver this line. Earth Day, right? Earth Day in 4 days from now. What will Earth Day mean in a synthetic age? Will it mean something we can understand? Or will it mean something that we find really quite alienating? So that's the question I want to leave you with. And I'd be happy to discuss some of these topics if you want to ask questions. Thank you. Yeah.
So thank you for the talk. This was really interesting. I think you, particularly the reflections on the future, really hit at the core questions, get right to the point. So I'm reluctant to kind of nitpick.
Oh, you should, though.
But so to go back to the kind of synthetic age versus Anthropocene distinction, I wonder when on one level that seems clear, but on the other hand, I mean, even terms like deliberate and intentional can be tricky. I mean, if you look at, throughout history, as you pointed out, the Dutch created land. Humans have, particularly in recent centuries, shaped the biodistribution of species. And the Nazis had de-extinction programs. So throughout history, I mean, humans have manipulated the environment, often on a significant scale. Certainly not on the scale we're doing today. So is that really, what do you see as fundamentally new? Is it just that we have a better understanding of what we're doing? Or are we continuing just these old processes?
Yeah. So it's a really good question, because it is very tempting to think, well, wait, we've already manipulated the whole planet, and especially with climate change. Because like the obvious thing with climate change is we have changed the thermodynamics of the planet, So
it's a question of scale.
Well, no. So I'm going to actually go back to this intention thing. So I do think intention matters. So one of the most famous prospective climate engineers in the country is this guy named David Keith. I don't know if you've heard about him. If you want to see him online, look up David Keith geoengineering, and a bunch of chemtrail stuff will come up online. Now, I don't know, are you familiar with chemtrails? Chemtrails is this sort of idea, it's a kind of out there, wacky idea that we're already getting poisoned by jets that are spraying stuff out of their engines for various nefarious purposes, right? So David Keith, unfortunately, his name has been associated with this chemtrail stuff. He's got nothing to do with this chemtrail stuff. And the chemtrail stuff is just sort of a fantasy. But anyway, I mentioned David Keith because he's very keen about researching solar radiation management. And this summer, out of Harvard, he and a couple of colleagues are going to run the first actual experiment on solar radiation management. They're going to go to Arizona. They're going to hoist a balloon up into the stratosphere. Then they're going to discharge first some ice and then some calcium carbonate. And they're going to see what first ice and then the calcium carbonate does to the optical and thermal properties up there. So it's the first field test of climate engineering. David Keith is into the idea of climate engineering, or at least the idea of researching it. David Keith insists that the Earth is not an artifact yet. He's actually published an article, and that's the title, Earth is not an artifact yet, because nobody has intentionally shaped the Earth on that planetary scale. So the difference between climate engineering and climate change is a morally significant difference. Climate change is an accident. Climate engineering is deliberate. And in the technologies that I chose, synthetic biology, I think is a really like a strong example of this. You are deliberately shaping something that is metabolic, something that is literally earth shaping, and I don't use that to be melodramatic, but you are deliberately bending in your direction a process or processes that give the Earth and its biota their shape. So, my claim is that never before have these impacts, big as they are, never before have they been intentional and process shaping in the same way as they are now. And I do get this question is the obvious one to ask, right? Is it really a sharp line that you're drawing? And it's probably not as sharp as I'm portraying it, but I do think there is a line here, and I do think it's something different. Yeah.
That slide you mentioned, the from atom to atmosphere, all
Yeah.
those concepts that you mentioned, which of those do you think would have the biggest ramifications, positive or negative, in terms of the synthetic age? Like gene engineering versus climate change, or nanotech versus the end of night?
Yeah, it sort of depends where you hang your hat, So this is the one you mean, right? So it's interesting. Like again, that's not this thing about line drawing. That's not like a perfect category. Like that right-hand side is not a perfect category. Some of them are a little less fitting in there than others. So one interesting thing to note, I think, is nanotechnology is widespread already. It's in thousands of consumer products. It's in many products that are in this room with us right now. And synthetic biology is not available, like the products of synthetic biology are maybe just beginning to become commercially available, but not. Climate engineering, like I said, first test this summer. So you can separate these out in terms of their impacts already, and then you could also sort of separate them out in terms of, well, what's their potential for global troublemaking, or global benefit, or global troublemaking. I mean, like the obvious one, climate engineering, I mean, that's global by definition, right? If you're changing the climate of the planet, by definition, that's global and has potentially major impacts for everybody, all 7.5 billion of us. Have we ever deployed a technology that impacts 7.5 billion people? Maybe someone will think of one right now, but it seems to be a different kind of technology. Gene drive. So one of the foremost advocates of gene drives is this guy called Kevin Esvelt, who's at MIT. And Esvelt has been pushing gene drives, particularly the ones that go into mosquito populations.
I think I've heard about that, actually.
Yeah. And this is a serious humanitarian concern. If you could do something about disease-carrying mosquitoes, you could create all kinds of good. So Esvelt has been pushing this for about 5 or 6 years. Last November, he published a piece, I think it was in the New York Times, where he basically said, 5 or 6 years I've been wrong. I completely underestimated the danger of these things. And the danger of gene drives is they sort of head out into wild nature. I mean, you literally, you alter the genetics of a few mosquitoes, and then you say, go, get out there, breed. And then it kind of heads out into nature. And what Esvelt has realized now, he sort of modeled the types of impacts this will have. And he realizes that you cannot actually limit gene drives in the ways he thought you could limit them. And so what he's recognizing is that gene drives essentially are this sort of technology without end that goes out into nature and keeps on spreading through populations beyond what you intend it to do.
It seems like that could also carry over for a lot of these other things too,
Yeah.
like climate engineering. You could start with the oceans, and by the end, you could be doing something like building a weather to create weather, like create a storm. Like in the Libby geostorm wasn't really that good, but
Yeah.
that was the concept.
Yeah. So yeah, that's a good point you brought up there. So the idea of climate engineering is to do what you need to do to cool the planet. Okay. But once you've done that, and let's say you do that well, maybe we could start some other stuff. You know, maybe we could design a slightly better climate, kind of make life harder for the Russians, a little easier for us, or something. You know, so it kind of spills over into other things. So the other slide I had up there, where I said it's easier to be a member of Earth First and the Chemical Manufacturers Association than neither. You know, I think that's appropriate when you think about these technologies. Like, I look at every one of them, and I say, fantastic! I would love that benefit. And then I also look at them and say, slightly scary. So then, like, as an ethicist, you got to say, all right, so what do I do? Do I, like, try and ban these people from researching? You know, people are trying to ban David Keith from researching stratospheric aerosols. Do you ban them because of the danger, or do you figure out ways to regulate the development of these technologies in a way that's going to be good for everybody? Yeah.
So I lost your exact wording, but you sort of ended the talk about Earth Day, and will we find something we can resonate with, or something that is sort of foreign? Who's to say which one is which? Earth 3 or Earth 1?
Do you mean who's to say which one we're in, or who's to say which?
Well, when we go to Earth Day, and,
Yeah.
and when we find something, who's to say which Earth is the Earth that we resonate with, and which Earth is the Earth that's foreign?
Yeah.
Is
Okay.
it Earth 1 or is it Earth 3?
Yeah.
Right? Because one can see them ultimately playing either role.
Yeah. So you know, this is a really good question, and I think, you know, as I was coming down here, so I come from the University of Montana, and somebody just was pointing out, you know, Montana's where you got all these writers and all these romantics, and you know, all these people who love wolves and bears and all that kind of stuff. And I thought, oh, I'm going to the School of Mines, you know, where there's a lot of engineers, you know, a lot of technology-oriented programs. And so, you know, I'm speaking to an audience where Earth 3 probably looks highly desirable. Whereas, you know, back in, I mean, this is a little bit of a simplification, but, you know, back in Montana, Earth 1, like the old one with the woolly mammoths, you know, that's the one people write their poetry about. Perhaps here, Earth 3 is what you write your poetry about. So, I mean, I guess I need to be humble myself and not say that Earth 1 is the one that we should all be paying attention to. But what?
I'm not saying one way or
Yeah.
really, but it's, you know, depending on what sort of fork one takes, if you want to go that route, you know, you could see in 100 years that really everybody says Earth 3.
Yeah.
That's what I resonate with.
Yeah.
And not Earth 1.
Yeah.
So, I mean, it's just an interesting way to perhaps think about that idea.
Yeah, I agree, and it's a really nice way to sort of frame what we're facing, and I thought to just bring this slide back up. I do think we're at this moment right now where we need to look ahead at Earth 3, and we need to look back at Earth 1 and say, well, what are we losing and what are we gaining? And let's make sure, whichever way we go, whichever path we choose, let's make sure that we choose it deliberately, thoughtfully, publicly, democratically. Let's make sure we're all involved in this decision. rather than just let business interests make this decision for us. Let's have a conversation about this stuff and make sure that if we are going to go that way, we do it with the right frame of mind, the right kind of self-knowledge, the right kind of awareness. Yeah.
Is there a way to know or guess how long this moment will last? Like, when do we need to make this decision? If there is.
By Sunday. Yeah, no, that's a really good question. So here's one response I've had in some Q&A. Like, you talk about planet-shaping technologies. What about the Haber-Bosch process for fixing nitrogen out of the atmosphere? And originally it was to make explosives, but eventually fertilizer, right? So that's 100 years ago. And it was metabolic. I'm using this metaphor of things that are metabolic to the Earth versus things that are cosmetic. If you're changing the nitrogen cycle, you are changing the metabolism of the Earth. And that happened 100 years ago. And obviously it's been sort of happening since. It didn't all happen 100 years ago. And then some of these technologies are not here yet either. So what is the period of time? Though I don't have an elegant answer to that. The period of time is longer than 10 years and shorter than 110 years, I think. I think we're in a window, and I don't know exactly how long it is. But since I don't know how long that window is, I suggest we start talking about it now. Yeah.
So this conversation we need to have about which way to take, is that being had by the same people who will implement these technologies, or is there a pretty big disconnect?
It's a good question. There isn't much of a public conversation about this stuff yet. Luckily, some of the people who are involved in these technologies are impressively self-aware. So I mentioned two people, David Keith and Kevin Esvelt. So they could have been people who just went hell-bent on developing synthetic organisms, in Esvelt's case, and climate engineering technologies, in Keith's case. Neither of them have done that. They've both said there's ethics here. There are serious ethical questions here, and we need to bring people in to talk about the ethics. So we are really lucky that some of these advocates for these technologies have been reflective about them and invited ethicists in to take part in these conversations. It's not the case for all of those technologies. I think synthetic biology has had some ethical discussions and oversight, but I think it's been a little limited. It's focused mostly on biosecurity issues. So like, could someone design a synthetic organism that could then be let out and kill us all? So that's been the ethical issue there. I'm not sure about nanotechnology. Nanotechnology is in the marketplace, and I'm not sure nanotechnology is being regulated in the way that might be appropriate. The Toxic Substances Control Act is a 1976 act, and a lot of that 1976 language was just sort of put on top of nanotechnology and said, all right, we're good. So there is a disconnect in some cases. In other cases, things are going better. I found this a very exciting arena to be an ethicist in, because people do recognize there's ethics here. And so, I'd invite all of you to sort of, every time you think about these technologies, think about what the ethical elements are and whether you too can be part of that discussion. Keep the ethics in view as these technologies develop. Oh yeah, sorry.
Earlier you mentioned there is a difference between environmental philosophy and engineering ethics. As someone who is going into environmental engineering, what is the difference between the philosophy and environmental philosophy and engineering ethics?
Yeah, good question. I don't have a sort of textbook answer for you on that one. I'm not very good at answering your questions because I didn't manage the last one very well either. So I think, I mean, broad kind of categorization. Engineering ethics has tended to be, first off, about sort of disciplinary practices, like what's ethical within the practice of engineering, research, and development and deployment, that sort of thing. So it's been practice focused and also human focused mostly. All right? Environmental ethics, on the other hand, environmental ethics is very much sort of rooted in the Holocene kind of stuff that I was talking about. Wild animals, wild processes, all that kind of business. So like as a crude distinction, like environmental ethicists tend to get into things like the debate about wolves and, you know, whether wolves have places on the landscape, this sort of thing. But they can, it's not a clear-cut distinction because environmental ethicists like me come over out of that into the engineering ethics arena and start to ask about, you know, what are these technologies doing to the fundamental relationships that we think about as environmentalists. So yeah, not a great answer, but I think that the environmental people tend to be a little more radical. I don't know any radical engineering ethicists. Do you, Chin, know radical engineering ethicists? Yeah.
It's good distinction.
One more question.
Sure.
So, moving to the future, I know you're talking about these windows of 10 years, 100 years. You know, people like Clive Hamilton say that to some degree it doesn't matter. I mean, the Anthropocene or the synthetic future is going to end at some point. I mean, humans probably aren't going to be around when the sun goes out.
Mm-hmm.
At least that's the argument made by some. So, do you agree with that? I mean, do you think that there will be a nemesis to our hubris, inevitably, that we can't sustain this synthetic future forever? Or is this something that could actually transcend the kind of natural limits of our species and extend our existence out indefinitely, so there would be no other epoch?
Yeah, that's a really nice question. Let me bring this slide up again. So when I wrote the book, initially, that one was not in there. And my agent said, you've got to write a chapter about posthumanism or transhumanism. And I said, why? I said, you know, I'm writing about nature and all the things we're doing to nature. And the agent said, you've got to write also about what we're doing to ourselves. And I thought, yeah, he's probably right about that. This is not an area, actually, that I know a lot about. But what I looked into it a little bit, enough to get, you know, a chapter in there on issues of posthumanism. And, you know, I encountered people like Ray Kurzweil, who suggests that, you know, our human future is not going to be a biological one. You know, we won't really need our biological cells forever. We can get beyond those. The body will be dispensable, and we can live elsewhere in some sort of computational substrate of some kind. Now, I think that's worth thinking about in this conversation. I find the prospect icky, though. You know, it's a prospect that kind of gives me the chills. It's a prospect that I can actually hardly relate to in any sort of a way. So it belongs in a discussion, but I don't know exactly where to leave it in this, you know, where to put it in the discussion. It's a difficult topic.
Have you seen Altered Carbon on Netflix? Kind of goes over this.
Oh, really?
Where
No, I haven't seen it.
Transcend the biological bodies, yeah.
Oh, wow.
Yeah, it's pretty cool.
I should see that.
It's like a electronic disc that they put in your head,
Uh-huh.
and as long as that doesn't get destroyed, you can transfer from body to body.
Oh, okay. Yeah. So then at that point, questions about the Holocene past and the romance for the Holocene past become all kind of irrelevant. Like, we're so far away from that, it just doesn't matter anymore. Oh, yeah.
So these are very large-scale decisions for like society to make that require a large amount of like money input and a large amount of, they have to have a large impact on people in general. So it kind of, I wonder who essentially has the authority to make these decisions. And then when I think about the kind of governing bodies that might have that, I realize that most of the people, or a significant number of the people who make up those bodies, have shown that they don't really understand or respect science very much, such as there was the incident where a congressperson brought in a snowball.
Yeah.
And he's like, this is proof global warming isn't real.
Yeah.
So even if we can properly determine what the right answer to these questions are, how can we trust that the right answer will be implemented?
Yeah. Yeah, you know, that's another, it's a good question. And I obviously paint a picture here, like an ideal picture. We need to talk about this. We need to decide it together. We need to not enter into this future accidentally and with regret, you know. So I paint this ideal picture that somehow we're going to get together and figure this out together. And you correctly point out, how the heck is that going to happen? Like, how are you going to have any kind of governance body that could make decisions of this kind of consequence? And how could we trust that body to implement what the science tells us is the way to go? There's not a sort of optimistic way to answer this question. So in climate engineering, there's a little organization called the Solar Radiation Management Governance Initiative, SRMGI. And what they're basically saying is, you know, if we're going to manage the climate for the whole planet, we have to figure out how to govern such a process. The first thing they figured out is they need to have the most vulnerable people at the table. You know, this must not be a decision made by Americans and Germans. This needs to be a decision made by people in Pacific Islands, people in the Arctic, people in sub-Saharan Africa. And in the climate engineering discussion in particular, there has been considerable effort to bring voices in from vulnerable nations so that whatever decision is made is a more representative kind of decision. But there's no sort of surefire way to make these decisions in an ethically sound, reliable way. We've just got to sort of do our best to get as many people involved as possible.
Any other questions? No? Okay. Good. Thanks, everybody, for your questions, for your interest and attendance here today. We thank Dr. Preston again for this wonderful lecture.
Thanks for coming.
Thanks, everybody, for coming.